day, everyone. This is the part 3 of thermodynamics. Still on Chem 101, Chem 101 or Chem 301, and I will still be treating thermodynamics. Please, but for this particular episode we'll be dealing with the laws of thermodynamics or thermodynamic law. But before we treat this, I wanted to know something about Gibbs free energy. The Gibbs free energy is also known as free energy, or we can also call it Gibbs energy. It is also known as, like what I said, Gibbs free energy is also known as free energy or Gibbs energy, and it is usually the driving force. It is usually the driving force behind every chemical reaction. So if you see a question like this in your exam, that the driving force behind every chemical reaction is 10 dash, please, your answer should be what? Gibbs free energy. And it is noted by delta G, whereby the formula is delta G is equals to delta H minus T delta S. I want to explain something here first before I enter the thermodynamic laws. I will mostly talk on the first laws. Second law and third law, they are kind of optional in your exam, but what you mostly see in your exam is calculation on Gibbs free energy, then majorly first law of thermodynamics, then little of second law, and maybe 300 level you see your third law. Now delta G is Gibbs free energy, delta H is which is the heat content, then T is your, what's it called again, your temperature, whereby your delta S is the entropy. Remember, the enthalpy, which is delta H, is also known as the heat content, which can be positive, can as well be negative, while your entropy can also be positive, can as well be negative. But please take note, entropy, like what I said in our last class, is the degree of disorderliness or randomness of a system. But there is something I wanted to know about this delta G. This delta G gives information on if the reaction will be spontaneous, if a reaction will be spontaneous or not what? Spontaneous. So delta G can tell you if a particular reaction, for example, if I give you a particular equation, the delta G can tell you if the reaction will occur on its own. That's what I mean by spontaneous, something that can occur on its own or not. For example, now our life is a spontaneous life. It occurs on it. So even though we don't want to go out to our years, let me use that, it's spontaneous. Even though we don't want to go out, it will still be counting. Most cases, we always say they are usually irreversible. So most cases, please take note of that. Spontaneous reaction, they are irreversible. Like your years, that you can't say, I don't want to be 10 years again, let me be 5 years. It is not possible. You can lie to us, but your years still remains the same. That's for spontaneous. Like a waterfall, I mean spring water. So a waterfall is usually spontaneous. You can't reverse it back to, like water falling from mountains, rock waters and all that. They are usually spontaneous process and they are irreversible. Why not spontaneous? These are things that they don't occur their own. Maybe because of it must be influenced by something. So that's for not spontaneous, and they are usually reversible. Most cases, please take note. So delta G, which is Gibbs free energy, the driving force behind every chemical reaction, has the ability to detect if the reaction is spontaneous or not spontaneous. So please take note of this. Another thing again, if delta G is greater than, delta G can be greater than 0, delta G can be less than 0, delta G can be equals to 0. So please take note. What I mean by delta G is that your Gibbs free energy, or at the end of your calculation, maybe giving a delta H minus T delta S, at the end of your calculation, if you realize that the value of your delta G, it is greater than 0, then we cannot say it is a reversible process, which is a non-spontaneous process. But if your delta G is less than 0, that means it is a spontaneous process. So for this case, our delta G is less than 0, it is spontaneous. Why, if it is greater than 0, we say it is not spontaneous. Then if delta G is equal to 0, we can now say the reaction is at what? Equilibrium. So I can also twist this again. A question might come in this format that if delta G is negative, is it spontaneous or non-spontaneous? So if you look at this range, we have 0 here. Here is always +1. Here is +2. Here is +3. Here is -1. Here is -2. So let me use this to explain something. Now, if someone tells you that if delta G is -2, or if the value of delta G is negative, is the reaction spontaneous or non-spontaneous? If it is negative, the first thing that should come to your mind is it less than 0 or greater than 0? It is less than 0. So since it is less than 0, the reaction will still be what? Spontaneous. That means it is irreversible. It can occur on its own. But if delta G is 0, that's to say the reaction is at what? Equilibrium. Why if delta G is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? That's to say your reaction is what? Not or non what? Spontaneous. So please take note of this. There are actually some calculation that you can search on, maybe go on internet or your textbook. You see some calculation on delta G. It's very, very easy. All of them, they are very, very easy. Just for you to insert the value of delta H, convert. If, for example, they give you 25 degrees Celsius, what you have to do, you have to convert this 25 degrees Celsius to Kelvin by adding 273 to it. But if you are in 300 level, you don't add 273. What you do, 273.15. This is what you add to it to give your answer. But for 100 level, you have to add just 273 to your answer to 25, which is you are converting from degrees Celsius to where? To Kelvin. So we usually solve with Kelvin, convert the answer to Kelvin, then they will give you the degree of designedness of the system, which is the entropy of the system. From there, they will give you the heat content as well. Then from there, just for you to impute your value of delta H, of the temperature, of delta S. Take note, delta H is the enthalpy, which is the heat content. The difference between the reactant and the product is what we call the heat content. Delta S is the entropy, which is the degree of the disorderliness or randomness of the system, while the T is the temperature of the body. Delta G, I already told you, is Gibbs free energy. Gibbs free energy, and it is also known as the driving force behind every chemical reaction. I believe that this is actually self-explanatory. Probably the video is already getting too long, so I thought I would just round up the whole thing before. So now, probably in our next class, I'll be dropping the first law of thermodynamics. I mean calculation that involve the first law of thermodynamics. Please stay tuned. Don't forget to watch the episode 4 of this video. And if you have not watched the episode 1, please try as much as possible to watch thermodynamics 1. I've uploaded thermodynamics 2, and this is thermodynamic 3. Probably in our next class we'll deal with thermodynamic 4. Stay tuned. Don't forget to share my videos to others. God bless you, and I hope to see you in my next episode.